Let's talk about what are the different things you can do with Lambda in the 2020. And I guess I should probably start also start with what do I actually mean when I say serverless? Because since AWS released the Lambda service in 2014, this whole idea of serverless became a thing. But for a very long time, it still happens now and then, even now. Whenever I mention the word serverless, somebody reminds me that there's still a server somewhere, which of course is just not the point. I think Goiko says it best when he says that serverless is serverless the same way that Wi-Fi is wireless, because even with Wi-Fi, you still have cables running around, but when you're connecting to a Wi-Fi connection, you don't think about those cables. They're not your problems anymore. So serverless is the same way that, sure, there's still going to be servers running your code, but they're not your responsibilities anymore. And typically when people talk about serverless, what we actually mean is any technology where you don't pay for it, where when nobody's using it, and you don't have to worry about provisioning the servers, managing, patching them, and the sort of scaling side of things as well. So in other words, it's very similar to taking a cab, whereby you start from having to own the car, having to pay for inspections every year, pay for road tax and all those things, and then you're going to rental where you don't own the car anymore, to using public transport, to just using Uber or something like that to just get a taxi, to just focus on getting to where you want to be. And the same evolution has happened from owning our own physical servers, where we have to manage them, patch them, get them added to our data centers, pay for cooling, all of that, to renting virtual machines on AWS or Google Cloud or Azure Cloud, where we don't have to worry about ownership of the hardware anymore, but we're still managing the operating system, the runtime for our application, to using containers where we don't even need to worry about the OS per se. We just worry about the actual runtime for our application and our code, to serverless, where we just have to write the code that's relevant to our business, so that we just focus on the business logic and let somebody else take care of all the infrastructure underneath that. So with the serverless, you have a few different changes in terms of how we build and run software, where before we spent a lot of time focusing on the infrastructure. Now we focus on what services we can use to achieve the business requirements that we have, and all the services that we're using are self-managed, and we only pay for them when we actually use them. So with Lambda, you're writing a very small piece of function that takes in some event and a context, and then you upload it to AWS, and then you let AWS call your function when something happens. For example, it could be a customer hitting a HTTP endpoint you have in API gateway, or maybe an IoT device that's sending a message to AWS IoT core, so that you want to process and react to those events. The great thing about Lambda is that it's auto-scaled by demand. So if there are lots of customers hitting your API endpoint, then Lambda will automatically scale the number of instances or number of containers running your code to meet those demands. And equally, when there's no request, the whole system also scales to 0, and you don't pay for those infrastructure, because you don't pay for those idle servers, because there's nothing running, and you only pay for invocations of your code. And when you're building APIs with API Gateway and Lambda, which is a very, very common, very popular use case for Lambda today, you also get multi-AZ out of the box. So both API Gateway and Lambda gives you multi-AZ out of the box, where you don't have to pay for those actual redundancy. You only pay for what you use. So in this case, a request comes in, you also don't have to worry about the load balancing across multiple availability zones either, because that's also a feature that's built into API Gateway. And oftentimes, you also see people building APIs with API Gateway, Lambda, and DynamoDB. So in this case, with DynamoDB, you can also configure your tables to be global tables. So in a case where you want to run, say, a multi-region active API, whereby if one region goes down, there's nothing you need to do. Just let the system deal with that and route traffic to a different region. It's kind of the our multi-region active is kind of the gold standard when it comes to building a highly resilient application. And so it's easy to see when it comes to why are so many of us so interested in the serverless, in that you get a lot of scalability out of the box, and you're able to scale from 0 to 3,000 containers essentially instantly, without having to pay for having those servers running around all the time, because Lambda is now the Lambda service is responsible for managing that massive pool of EC2 instances, so that all of their customers can tap into when they need to. And your systems can often be much cheaper. In fact, I've heard quite a few companies talk about how they save 90% of their AWS bill, because when they move to Lambda, they don't have to pay for idle servers anymore. And you also get a lot of resilience out of the box, because you get multi-AZ, again, out of the box without having to pay for those extra redundancy yourself. And your application is also more secure as well, because AWS is now taking care of the security of the operating system, patching them whenever there's a new vulnerability that's been reported, and also patching and securing the networking as well. But the most important thing for me when it comes to why serverless is that from having an idea to having something actually running in production and test the idea against the market, there used to be so many things I have to do. Now, when it comes to serverless, a lot of them have become either irrelevant or have been drastically simplified, because you get a lot of it out of the box. And that means in return, I get a lot of velocity to go from having an idea to being having something running in production, so that I can test those ideas against the market. And as example, recently I worked on a client project where we essentially build a social network for a Belgium client in under a couple of weeks. And I remember, back in the days, it used to take me a couple of weeks just to configure all of the things I need to do for my application from the infrastructure point of view, in terms of auto scaling, launch configurations, patching AMIs, and all these other things. But nowadays, I can actually just build and ship the whole product, MVP for a product in just a few weeks. And I can do that because I can minimize the amount of undifferentiated heavy lifting. So, things that aren't core to the business value that I provide to my customers, and I can reduce the amount of operational responsibility that me and my team have to take on, because less things are for us to manage, more of them are being managed by AWS. So my name is Yan Cui. As Carlos mentioned, I often go by the moniker the Burning Monk. I have been a long time AWS user. I've been using AWS for production workloads for more than 10 years, and I'm an AWS serverless hero. The last couple of years, I focused mostly on serverless technologies with Lambda, and I've built quite a few applications, one of which was moving a social network to run entirely on serverless. You can read about it on the link here. Nowadays, I spend half my time working with Lumigo as a developer advocate, and Lumigo is a troubleshooting platform for serverless applications. Think of it as a really powerful version of X-Ray, where you can also get information from the logs from your functions all in one place without having to do any manual instrumentation yourself. The other half of my time I spend working with direct clients as an independent consultant, where I help companies around the world adopt serverless the right way and be successful with serverless. In terms of training, in terms of advisory, and sometimes working with clients to actually to build and deliver MVPs for their products. In my spare time, I've done a few books and video courses with Manning, and I've also self-published a few video courses on the Lambda and the step functions as well. And as Carlos mentioned, I also host a real-world serverless podcast where I speak with other people who are using serverless in production, and their experience and what works and what doesn't work for them. So check it out at realworldserverless.com. But that's enough about me. I want to take you back to talking about what you can do with Lambda today, and we already talked about the API use case. In fact, this is probably accounts for like 30-40% of the what people are doing with Lambda in terms of the last set of numbers I saw AWS publish. The main argument against using something like API Gateway is that it can be quite expensive. So as of last year, API Gateway also released a new a new version called HTTP APIs instead of REST APIs. The main difference is that well, it's a lot cheaper. So where you pay $3.50 per million requests to API Gateway, you only pay $1 for HTTP APIs. So like for like, it's much cheaper. However, there's quite a few features that's available in REST APIs that's not yet available in HTTP APIs just yet, including the ability to use IAM for authentication or using a custom Lambda authorizer function. So if what you need to do can be done with HTTP APIs, then you should just use HTTP API because it's a much cheaper alternative compared to REST APIs. Of course, when it comes to building APIs with Lambda, you can also use ALB as well, which has got a more, I guess, complicated way to calculate your cost because it's based on this concept of load balancer capacity unit that you can determine based on a number of different factors. So on sort of low throughput scenarios, it can be more expensive than API Gateway. So assuming that you are doing 1 transaction per second, then this is what your cost is going to roughly look like per month. And as you can see, because you have to pay for uptime for capacity units for ALB, it can be more expensive here. But as you scale your application to say 1,000 requests per second, then once you calculate how much load balancer capacity unit you are likely to need for ALB, you might see that it's going to be significantly cheaper compared to API Gateway, both REST as well as HTTP APIs. So in AWS, a general rule of thumb is that if you have a high throughput requirement, so you're talking about thousands of requests per second, then you should consider services that you pay for by the hour because they are typically order of magnitude cheaper when running at scale. And in terms of ALB, it's also got a few other things that API Gateway doesn't have. For example, API Gateway does have a canary support where you can route traffic to different versions of the same endpoint, but it's not sticky. So the same user can be going between your canary branch to your main branch constantly from one request to another. Whereas with ALB, it's sort of weighted traffic weighted routing supports the stickiness so that the same user will always go to the same branch, and also support the more advanced routing based on HTTP headers and query string parameters and so on. But when it comes to building APIs, the common question people have for Lambda is that, well, what about cold starts, where if it's a new container, then it's going to be much slower, whereas for my API, I really need to have a much predictable and low latency. So I would say, first, you should try to optimize your cold start duration. So this is where you try to improve your code by reducing the amount of dependencies that need to be loaded during cold start, so that hopefully even when the cold start happens, they always fall within your acceptable latency range. So if your SLA is that 99% of requests should be completed within 3 seconds, then you can quite easily optimize your application to achieve that with even with cold starts. But sometimes when you just can't do that because maybe you're writing your API code in the Java, where the cold start is still much more significant compared to Node.js or Python or Go functions, then what you could do instead is use a new feature in the Lambda called provision concurrency, which essentially allows you to say, I'm going to pay extra to have a certain number of containers that are always warm and ready to handle requests, rather than have to have always this on-demand scaling. The nice thing with provision concurrency is that it also works with the on-demand scaling behavior as well. So when there's more requests than the warm containers is able to handle, then the Lambda will also scale up more containers on demand, but then you start seeing cold starts at that point. So REST APIs is very, very common use case for Lambda in nowadays. Another sort of interesting question is, well, I've got REST API, but also want to have WebSockets. What can I do with that? With WebSockets, you can implement it a couple of ways using API Gateway, AppSync, as well as IoT Core. So with API Gateway, AWS announced the support for WebSockets for API Gateway back in 2018. So the way it works is that when somebody connects to the WebSocket connection on API gateway, you can have a Lambda function handle the onConnect event. So this is where you're going to get the connection ID that identifies that particular connection on API gateway, but it doesn't have any sort of logic to help you identify which user is on which connection. So that's something you have to do yourself. Typically, you will have the Lambda function take the connection ID, look at the user's authentication header, so potentially, the user is authenticated with Cognito. Then you would store the mapping of the user ID and connection ID in DynamoDB. And equally, when a user disconnects, you can handle that onDisconnect event with Lambda to remove that mapping. So that when your application actually needs to send an event to a particular user, you can have a Lambda function, maybe as part of some background task, look at the mapping in your DynamoDB table to say, for this user ID, something, what is his connection ID on API gateway? And once you have that, then you can send a message to that connected device or that user using an API call to API gateway with the connection ID. So as you can see, this is quite a low-level construct where you have to manage the connection mapping yourself. There's no support for doing any kind of broadcast. So if you're implementing a chat room, you have to implement that mapping of the connection ID to the sort of chat room ID yourself. And if you want to broadcast messages to, say, 1 million connected device users, then you have to essentially fetch 1 million items from DynamoDB and then make 1 million API calls to API gateway. So as you can imagine, it's really not very efficient, and also can be quite expensive in those use cases as well. So with AppSync, AppSync added support for real WebSockets last November, so that's 2019. In this announcement blog post to talk about how that works, and also to talk about the fact that with the real WebSockets for AppSync subscriptions, you can now achieve millions and millions of connected users. And so the way it works is that it's tied to the GraphQL subscriptions, so that essentially a particular user can subscribe to a particular event or subscription. I guess the type changes to a particular type, so that whenever you're making a mutation to that type, then you can send an event to the people that subscribe to that changes to that particular type. So with AppSync subscriptions, it's very scalable, it's quite easy to use because it's all tied up in the GraphQL subscriptions, but it also means that you have to end up using GraphQL as well. So it's not just plain WebSockets, but you have to use GraphQL subscriptions and then use WebSocket on top of that. And then there's IoT Core, which allows you, which is not just for IoT devices. You can also just use it from anything. Because it also supports WebSocket protocol as well. So essentially, it will be sending MQTT messages, which is this, I guess, a messaging protocol over WebSockets. The main downside of using IoT Core is that you have to sign your requests using AWS Signature v4. So typically what you end up doing is that you will have your application obtain some temporary AWS credentials by signing in as either unauthenticated or authenticated user with a Cognito identity pool, and then use the temporary IAM credentials to then access IoT Core. So you have to sign your requests, your request to WebSockets using the AWS v4 signature. And then also the messages are wrapped up in the MQTT, not just plain messages. You have to be the messages are delivered over WebSocket in MQTT format. So it's not particularly, I guess, easy to use with API Gateway, but you do have a few other options here when it comes to when you want to do WebSockets with Lambda. So we talked about AppSync already. So this is where if you want to build a GraphQL API instead of a REST API, where you can have AppSync as your GraphQL server that takes your schema, and then you can define for each of the mutation or query or different types or nested types how to resolve them. So they can be linked to DynamoDB tables or Elasticsearch clusters or RDS databases, or use Lambda as well to proxy to other things. So with AppSync, you have this very scalable GraphQL server, and it's multi-AZ out of the box, and the subscriptions also scale to millions of connected users, which is great. And you only pay for what you use at the price of about $4 per million requests. Slightly more expensive than API Gateway, but at the same time, you probably end up needing fewer requests because you can do more with one request with GraphQL than with REST APIs. It's got the built-in caching as well, but you have to pay extra for that. And also has got built-in integration for metrics and logging with CloudWatch and CloudWatch logs. And you don't have to manage any servers. You just say, here's my GraphQL schema, and for each of the query or mutation, and what does that resolve to? It could be a Lambda function, it could be a DB table request directly. It's really, really powerful, and you can really build something very quickly. So those are probably the main sort of the HTTP-based APIs that people are building nowadays, and they can all be supported on Lambda quite easily. What about when you have sort of big data, you want to build some kind of data pipeline with serverless and serverless technologies? Well, here is also a very common use case with Lambda in combination with Kinesis as your real data stream, where you can have application or other things publishing to Kinesis stream, and then you can have a Lambda function that processes them in real time. So I recently spoke with Anahit on the Real World Serverless podcast, where she was talking about a project she's been doing with the Finnish national TV broadcaster, where they are processing something like 200 or 300 million messages per day with Kinesis and Lambda. So Kinesis is very, very scalable service, and you can process events with Lambda very easily as well. And another thing that you can do with Kinesis is that oftentimes you will have Kinesis as your sink, and then Lambda to process those events in real time, but then you want to also archive them for later. So in this case, you can use Firehose, Kinesis Firehose, to connect to the main data stream, and then Firehose can then buffer the data and then batch them and put them into S3, so then you can run ad hoc queries against a vast amount of data in S3 with as a data lake using something like Athena. So Athena can run ad hoc queries against your data in S3, and you can scale to many exabytes of data and still run queries very, very quickly. And sometimes you also want to do real-time aggregates, maybe like rolling averages for, say, 5-minute averages of number of users who signed up to the application. You can do that with Kinesis Analytics very easily. And in terms of the output, once you have those rolling aggregates, you can output them to Lambda functions, or potentially to another Firehose stream, and then you can then buffer them and so on. Or you can also pipe them to another Kinesis stream, so they can have other Lambda functions or other things that listen to those events and then process them in real time. So in terms of big data, Kinesis, Firehose, Lambda, those are very common tools that people use to build these kind of systems. Even for systems that feeds data into machine learning algorithms, and sometimes you also then use Lambda and API Gateway to do those real-time recommendations, serving, and things like that. But what if you say, well, no, that's all great, but I'm an ops engineer, so I'm mostly focused on the infrastructure side of things and automation. So what can I do with Lambda for DevOps? Well, a lot of your cron jobs can then move to EventBridge, and you can, in this case, configure a rule to run basically every, couple of hours, every couple of days, or even every couple of minutes, or use a cron expression, and then when that job is triggered, then run a Lambda function. So you can put all of your cron job logic into a Lambda function, and then use EventBridge schedule to trigger that function on some kind of a cron expression. Or in this case, you can have other rules to listen to events happening within your AWS account. So in this case, I can say, well, I want to do something every time someone creates a new CloudWatch logs log group, so that I can then subscribe it to some Lambda function, or so that I can process those log messages and ship them somewhere else. In this case, you can You can find a lot of events that other AWS services are publishing to EventBridge directly, but also if you have Cloud Show enabled, Cloud Show can catch other API calls from other AWS services, and then they will then be available to your Lambda functions through EventBridge. And Cloud Show also collects the users that are logging into the systems and so on, so that you can also use that to say, well, when someone log into the system, please ultimately log on to AWS Console, trigger Lambda function to see, okay, are they logging in from the right location we know about, so that if someone logs in from locations where you have no employees, then okay, maybe something fishy is going on there. Another sort of common case, use case for DevOps or DevSecOps is using AWS Conflict to enforce governance in terms of how AWS resources are configured in your account. You can use Lambda here in two different ways. One, you can implement a custom config rule in AWS Config with a Lambda function, or I'm seeing now quite a few people are doing the sort of automatic remediation. So this is where AWS Config has identified a resource as has been non-compliant with your configuration rules for your organization. It could be they left a S3 bucket open, or they have created Lambda function with a star as a IAM policy, so that that is in violation to your organization rules in the AWS config. Then that becomes an event that AWS config is going to publish to EventBridge that you can listen in via EventBridge rule to trigger Lambda function to automatically do something about that resource. So Lambda is often used by these DevOps teams or DevSecOps teams to automate a lot of things they have to do within the AWS account. And then for many businesses, they have more complex workflows that can't be done by just a single Lambda function. Things like taking payments, signing up users, which sometimes you have asynchronous processes that have to happen outside of the loops that someone have to click OK to an email or something like that. So this is where step functions comes in. So step functions is an orchestration service that lets you model your business workflow as state machines. So it manages state for your workflow, keeps track of where the execution is, and giving you this nice and scalable and resilient platform to build on top of, and allow you to focus on just writing the business logic instead of managing the infrastructure and dealing with state management. So in this case, with step functions, you design your state machines using this JSON-based language. And you can design the workflow. If you design a workflow in the AWS console, you can also visualize your workflow using the visualization tool they have right there. And also I find this really useful for when you are collaborating with non-technical users, so that they can easily follow along with what I'm doing, rather than getting distracted by the sort of JSON syntax, which is very great for designing those workflows collaboratively. And in terms of once you've defined your state machine, you can start an execution with some input. So in terms of sort of semantics, think of that as your definition for the state machine. In JSON is your class in OO, and then an execution is an instance of your class, which you start by providing some constructor arguments. You can start a state machine execution a couple of ways. You can start it using the AWS console, or using the AWS SDK or the AWS CLI. Ultimately, just calling the step functions the start execution API somehow. But you can also trigger a step functions execution via API gateway directly without involving Lambda functions or anything else. And you can also trigger EventBridge step functions using EventBridge, including using a cron job. So if you have some business workflow that you want to model using step functions and you want to run it as a cron job, you can do that really easily with EventBridge and step functions as well. And if you're designing your state machines and you're deploying them with the serverless framework, then you can also design and write your Lambda functions and deploy everything together and deploy them in one go as well using the serverless framework. And in this case, once an execution has started, you can also track its progress in the AWS console using this visualization tool. So where you have like branching logic and things like that, you can see the actual path that a particular execution took, as well as the input and output at every single stage of your state machine. So this allows you to really quickly identify, what's actually going on in the state machine and find information about like why you failed, for example, and the different stages, different steps of your state machine you may want. So some of this can be task states where you can trigger a Lambda function to do some work. And step functions also records up to like 25,000 events, so that in its event history you can see which Lambda function ran at which and also you can have a shortcut to the CloudWatch logs to see the logs for that particular function. And finally, in your state machine, every single step is called a state, and then going from one step to another is called a state transition. And the way step functions is priced is that you pay for the number of state transitions, which is about $25 per million. And that makes it one of the most expensive services on AWS, and easily an order of magnitude more expensive compared to the Lambda cost you will likely incur as well, that from step functions calling Lambda for different states. So to address this cost concern, AWS released a new sort of variant of step functions last year called the Express Workflows, which is a more scalable and also cheaper alternative to the normal state machine workflows. In this case, it's called the Express Workflows, whereas the other one, the normal one, is called the Standard Workflows. So with Express Workflows, you are limited to just 5 minutes of runtime compared to up to a whole year with the Standard Workflows. But with Express Workflows, you also it's designed for those high throughput transactional systems. So you don't get the visualization tool, but you still all the audit history in the console. But instead, all the logs, all the events are shipped to CloudWatch logs instead. And in return, you can start something like 100,000 of these Express Workflows per second. So it's super scalable. And in terms of adoption for step functions, a lot of customers are using step functions in production already, including people like Coca-Cola and iRobot and Thomson Reuters. And I actually have got a video course just on step functions. So if you want to learn how to use the functions, when to use it, then check it out afterwards. So business workflows can be implemented using step functions and Lambda quite easily. Another quite common sort of use case I've seen quite a few times now with my own clients is sort of video encoding, video encoding. So this is probably one of the first use cases that really AWS designed the Lambda for, whereby someone can drop a file into S3 and that can trigger a Lambda function to do something. So in this case, if I drop a video file into S3 bucket and that triggers a Lambda function, I can use Elemental Media Convert to then to encode the video for different devices and different dimensions and so on. And then the Elemental would then spit out the output files into another S3 bucket. In general, when you're encoding videos, you can expect that if the video is like 10 minutes long, it's going to take 10 minutes to encode as well, which if you're doing lots of videos, for example, like media sites, for example, it's probably not great because that's going to take a lot of time. So one of the things you could do is use the step functions, whereby you can take the video file from the S3 bucket. You can use a Lambda function to split that video into many smaller segments using FFmpeg. And then it's got this map state, which essentially allows you to dynamically take an array and then dynamically create a number of concurrent executions for this Lambda function to process each of the items in your array. In this case, you can then use the Lambda functions and use the FFmpeg to encode different segments of your bigger video file and then spit out its output, and then the map state will actually collect those output from individual parallel branches and then put them back into an array, so that you can have another step that comes after this map state to then take those encoded segments and then stitch them back together into a bigger video file and then put them into S3 as your output. This is exactly what Thomson Reuters is doing, and with step functions to encode videos much quicker. So they were doing this, they're able to reduce the sort of processing time for their videos from averaging 20 minutes to just under 2 minutes. So video encoding is another quite common use case I've seen with a lot of people. And then like another one that you probably hear a lot about is this event-driven architecture, where instead of having lots of APIs calling other APIs, you have microservices that just emit an event when something happens, and then other microservices will listen to this event and do their own thing. So you can build a very expensive system in a loosely coupled way. And sort of the question often gets asked is, okay, that's amazing, that's great, but what do I use as my event bus? And increasingly, I would say you should use an event bridge as an event bus instead of SNS for a couple of reasons. One of the reasons is that with SNS, you only have a very small number of targets, whereas with Event Bridge, you have huge number of different targets you can forward the messages to. And also, when you have an event bus for your event-driven architecture, you also want to have some way to manage the schema. So with Event Bridge, it has got this schema discovery mechanism that you can enable on an event bus. And so Event Bridge will sample the events that's coming into the bus, and then you will figure out what the schema is for those events, and then you can then find those schemas in one of the schema registries that you have in the Event Bridge, or you can publish schemas to the Event Bridge schema registry yourself as well. So it's a very nice way for you to have a centralized event bus where everyone can find out, okay, what are the events I can find on this bus. And also, probably the most important thing that you get with Event Bridge that you don't get with SNS is that you can do filtering based on the content. Whereas with SNS, you can only do filtering based on the message attributes, which really stops you from being able to having one single topic for all the different events, because you're limited to what you can filter the messages by attributes. With Event Bridge, where you can filter the events by content, means that you probably just need to have one bus for all the different events you have in your system, because you can just filter on the content very easily, with a very flexible way rules that you can create. And furthermore, we talked about how Event Bridge can ingest events from other AWS services, such as step functions, such as AWS Config and CloudTrail and other services as well. And also the application itself can publish its own custom events to Event Bridge, and Event Bridge can also ingest events from other AWS partners like Datadog or New Relic, so that whenever you have an alert, rather than creating lots of different webhooks, you can just configure Event Bridge to ingest events from those third-party partners, so that you have one place to ingest all the events, and then you can create rules to react to, okay, what should I do when we have an application alert in the New Relic, for example. You can then create rules around those events, and then use those rules to then target individual Lambda functions to do something. And when your functions is processing this event and is causing some state changes, you can also then publish events back into the Event Bridge bus, so that you can then trigger other functions to run as well. And when you've got this sort of event-driven architecture where lots of things are firing asynchronously, a good question to ask is, well, what do I do? I mean, how do I handle when something goes wrong? How do I handle failures and errors? With Lambda, with async invocations, you can configure DL already, a dead letter queue already, whereby after the built-in number of retries has been exhausted, the event will then be put into either a SNS topic or a SQS queue. Normally we use SQS queue for the DL queue. And since last year, AWS also announced a new thing for Lambda called the Lambda Destinations, where you can also use for async invocations. And in this case, when the built-in number of retries has been exhausted, you can configure the destination for on-failure branch, on failure condition, to then put the events into an SNS, SQS, Lambda, or Event Bridge in this case. And the difference to DLQ is that your payload includes both the request as well as some information about the request context, but also importantly, the response as well. In the case of failure, you're going to see there is the exception. So this solves the common problem people have with a DLQ, is that, well, I've got a payload, but really don't know what was the error that caused these events to go into the DLQ in the first place. So I have then go to my logging system to actually figure out, okay, for this event, how many times was it processed, and why were we not able to process it successfully. Whereas with the Lambda destinations, you get the last exception before the message got sent to the destination, so you can see that without having to go to a separate system to find out your logs. And also, once you enable either Lambda Destinations or with the DLQ, you see these additional metrics in the monitoring dash tab on your Lambda function. You should set up alarms against those so that you know when the Lambda is not able to forward events to your DLQ queue or to your destination. So another nice thing about this Lambda Destinations is that it also works with stream-based invocations as well. So Kinesis streams or DynamoDB streams. So nowadays, I would say if you're thinking about using a dead letter queue, you should prefer using Lambda Destinations over the sort of standard DLQs you get with Lambda. But you may also notice that you also can have this on success condition as well. So instead of just using it for DLQ, you can also use it when your function finishes something successfully. So this is useful when you've got a very simple workflow, maybe 1 or 2 steps, where step functions might be overkill considering the extra complexity and everything that it brings. So instead, you just have a Lambda destinations instead to have that one hop workflow implemented using destinations on success. But anything more complex than that, you can still have step functions to model your more complex workflows. So for event-driven architectures, Lambda and Event Bridge is probably your bread and butter when it comes to the technologies you will use to implement these kind of systems. And finally, you've got Alexa, and you can build Alexa skills with Lambda. I'm not going to talk too much about this because I haven't done this myself, so I don't really know the ins and outs of this. But this is something that's becoming more and more popular as Alexa itself has become more popular as well. And also, finally, you've got the IoT devices like iRobot, Zumba, where you can have those IoT devices publish message to IoT core and then have Lambda function react to those events in real time. So those are just 10 use cases that many people are doing with Lambda and nowadays. So when I think about what use case, when people ask me what use case is right for Lambda and serverless, I think increasingly the question should be flipped around: is when is serverless not the right choice? Because pretty much any use case you can think of can be done with serverless. When is it not the right choice? I think this depends on what is your non-functional requirements. I think the big question to ask there is, given your non-functional requirements, can Lambda actually meet the performance and scaling requirements you have? So with Lambda, you are going to get cold starts from time to time. Even with provision concurrency, it's still possible to have cold starts when you don't have enough, when you haven't provisioned enough warm containers. So can your system tolerate occasionally a longer invocation time? And also with Lambda, you get auto scaling out of the box, which is great, but there are some scaling limits. The most important one to consider in this case is that for most regions, you can go from 0 to 3,000 concurrent executions or containers running at the same time straight away. But after that, you can only go up by 500 per minute, which means if you need to go from 0 to say 10,000 concurrent executions very quickly, then you need to it's going to take you 0 to 3,000 straight away, and then 7,000 divided by 500, 14 minutes. So it's going to take you 15 minutes to reach that peak concurrency. So this is where you could use provision concurrency to work around that. But by the time you need to do all of that, maybe it's worth just moving some of that workload to run on containers, because Lambda can meet your scaling requirement, but you have to do a lot of work to get there. Another thing to think about is in terms of the total cost of ownership for your solution. For serverless and for containers, or for EC2, is the same when it comes to think about, okay, for my total cost of ownership, there's the cost of running the system in terms of my AWS bill, but then there's also the cost of the engineers that need to work on this system. Oftentimes, I see the mistake people make here is that, well, I've got this system that would be maybe slightly cheaper to run on containers compared to serverless, but not taking into account the fact that, with that, you may have to spend more engineering time to work on a solution. So overall, you end up paying a lot more, because in most companies, engineering time is way more expensive than what you pay on AWS. And so a report came out, I think, a while back from AWS about how, in terms of sort of the staffing requirement for projects using serverless technologies versus not using serverless. And you can see that in terms of staffing, there's a massive difference here, like 80% difference here, where you can have few engineers get the same amount of stuff done with serverless compared to not without serverless, which means you can save a huge amount of money for your project, because for vast majority of companies out there, staffing costs outweighs what they will pay on the AWS bills, on the infrastructure cost. So overall, if you can reduce your staffing costs by a huge amount using service technologies, you can also cut down your total cost of ownership for your application way down as well. That said, sometimes you do have use cases where you may have a relatively simple application, but that need to run a very high throughput. I worked on several games where the application itself is kind of simple, but we were running at tens of thousands requests per second. So, the staffing cost is much smaller compared to the infrastructure cost. So for those systems or those specific APIs, it makes sense for you to maybe run them on containers on EC2 instead. That said, chances are, unless you're migrating an existing system with very high throughput requirement to AWS, you're probably not going to go get to that level of throughput straight away. So start with serverless, so where you can move very quickly, but where then you need to start to optimize for cost, then move things to containers. And with that, that's everything I've got for today. If you want to learn a bit more with serverless and Lambda, and what are some of the best practices that you should deploy in terms of scalability, resilience, and and cost optimization, then check out my video course, where you can find them at the lambdabestpractice.com. And I'm also working as a consultant, so you can also get in touch with me as well through my blog, theburningmonk.com, where we can see how we can work together to help you succeed with serverless. And with that, thank you very much for your time, and I hope you guys have enjoyed this session.